Okay, Assalamualaikum. My name is Muhammad Kamal Safarudin. I'm from Group 5. So Group 5 will present a video about application of differentiation and integration and vector value functions. Okay, now I will move to the objective of our case study. So the objective of our case study is we can understand how a function changes as it inputs for the primary aim of differentiation. Next, we can know that the ratio requires adding up a small part to find the entire amount. And third, we know that vector calculus extends the concept of calculus to function of multiple variables. Now we move to the methodology of our case study. For differentiation, we use four rules, which is power rule, product rule, quotient rule, and chain rule. For integration, we use three rules, which is first power rule, constant multiple rule, and sum and difference rules. Okay, for the vector, if we can use formula of vector addition and subtraction. Next, we can use formula of dot product of two vectors u and v. And also, if we want to find velocity and acceleration, we can use this both for the formula. Now I will move to the question. Now I will explain the answer for the question 1. So for the first answer, we got negative 3, which is decrease. For B, we got 6, which is increase. And C, we got 2.25, which is shows increase. Now we move to the question 2. So the answer for A is we get the initial radius of the sphere is 4 centimeter. For B, we got the radius of the sphere decrease at rate of negative 1 over 9 centimeter per second at t equal to 2. Now I will explain answer for question 3. So the answer by using the chain rule, we got 8 pi r. Now I will explain the answer for the question 4. For A, we got 1 over 2x and dA over dt. For B, when x equal to 3, we got the increasing rate of the surface area is 12 centimeters square per second.
Hello, my name is Muhammad bin Ismadi. So I explain the question number 5. The final answer number 5 is volume is decreasing at the rate 25 centimeter cubic per second, and I can show you the step of calculation A and B. For the next question, question number 6, the final answer is 32 over 3, and we calculate from the graph and calculate the next step. For the question number 7, based on the graph, and x equal to 0, y equal to 1. When y equal to 0, x equal to negative 1. When y equal to 3, x equal to 2. When y equal to 1, x equal to 0. And the final answer is number 2. Now we move to the question vector. Number 1, A, B, and C. We draw four graph with the point given, and we can see the four graph. Thank you.
So vector number 2, question 2a, I add the question f and g, I get the answer. And question b, I multiply f and g. For c, I use dot product f and g. For last, question d, I take the answer from question b and then I use dot product with equation f and thus I get the answer. For question 3a and b, I just use higher order derivative to get the answer. So for question 4a, first I differentiate rt, then I substitute 1 into derivative rt, then normalize it. Then I find t, which is vector tangent. Last, I find nt, which is unit normal vector by using cross product and using right hand rule. So conclusion for question 4a, at t equal to 1, vector tangent is 2i plus j over square root 5 and unit normal vector is 2 over square root 5i minus 1 over square root 5j. For question 4b, I use same method as 4a, which is find the derivative of rt, then substitute 1 over 3 pi into derivative rt, then normalize it. Then I find t, which is vector tangent, and then I find the unit normal vector, which is nt, by using cross product and using right hand rule. So conclusion for question 4b, at t equal to 1 over 3 pi, t is negative square root 3 over 2i plus 1 over 2j, and nt is negative square root 3 over 2i minus 1 over 2j. Question 5a, first I differentiate rt to find velocity and then differentiate again velocity to find acceleration. For curvature, I use kt equal to modulus velocity over modulus acceleration to find answer, which is 1. So for question 5b, we use the same method as 5a, which is differentiate rt to find velocity and then differentiate velocity to find acceleration. For curvature, I use kt equal to modulus velocity over modulus acceleration to find the answer.
Assalamualaikum. I'm going to cover the question vector for number 6 to 9. Go to the question number 6. Find the curvature and then the radius of the curvature at the starting point. First, we differentiate the first equation to get the velocity vector. And then we differentiate the velocity vector to get the acceleration vector. And then we compute the curvature k using the formula given. And we got 0i minus 16j. And then we make a cross product to get the answer is 48. And then we do the formula for this, then we get 8.54 and k is 848 divided for 8.54 power of 3 and radius is 623.71 divided by 48. Same goes with the question 6b. First we differentiate the first equation to get the velocity vector and we differentiate the velocity vector to get the acceleration vector, and then we compute, get the answer, which is 0i plus 2j plus 1k, and we made a cross product and we use the formula v1 for the velocity vector, and we get 5.657 divided by 3 power of 3 for k, and radius is 27 divided by 5.657. For question 7, given the vector valued function and then find the unit tangent vector, principal unit vector, binomial vector, and the curvature at t equal to pi. First unit tangent vector t was given. First compute r prime and then evaluate t equal to pi. And then second, we need to precipitate the unit normal vector. Then first compute t prime. We got answer 2.236. And then we use binomial vector, compute b, pi. And then lastly, the curvature at kt, we get the answer. K pi is 2 divided by 2.236 power of 3 and radius is 2 over 11.80. For question 8, evaluate the following integral. We must separate the component into 3, which is I, j, and k, and we must integrate all the component. Using the cross product, we can get the answer. So with the same as the same with the question B. First, we need to separate with 3 component I, j, k, and integrate all the component to get the final answer. And lastly, for question 9, find the function LT that satisfy the following condition. Same like question 8, we must separate the equation to 3 component I, j, k, and then integrate all of the component. But with this question 9, we got the resultant vector, and then we need to complete the resultant vector for all component I, j, and k to get the final answer. Same goes with the question B. Integrate all the component I, j, k, and then we find the resultant vector for all component I, j, k to get the final answer.
Okay, for question 11 is about use the given information to find a position vector r. Okay, for find the vector r, we need to just make some integration, and then we get the value at here. After that, we need to find I first, and then we need to find a j. After that, because k there has a no value, so we need to write as a team, and then we get the calculation is about t power of 3 over 3 plus 1, and then e power of 2t over 2 plus 3 over 2, and then t power of 2 over 2 plus 1. Okay, for question B, we just write it back, and then we make some integration. So we need to simplify it, and of the cost, we need to change to the sin, and then we get 4 over 3 t 3 power 3 over 2 plus c1 sin t plus c2. After that, we need to find a value of I, so we get 1, and then the value of j we get c2, same as 2, and for the total or conclusion is about 4 over 3 t 3 over 2 plus 1 sin t plus 2. So that is the answer for the B. Okay, for question 12 is about the velocity. So this is the question, and then we make some integration. Then we need to simplify it. After that, we need to find the value of I, j, and k because it's about the vector. So for the I, we get c is same as a 1. For c2, we get a negative 1. And for k, we get 2 over pi. And for the total, we get e power of t plus 1 and 2t over power of 2 negative 1 and negative 1 over pi cos pi plus 2 over pi. Okay, for this question, we need to find the acceleration. As we can see at here, the question is about cos 2ti minus 4j plus e power of 2tk. Okay, from this question, we need to make some integration, and after we get the doing the integration, we get this answer. And after we get this answer, we need to find the value of I, j, and k. So for the value I, we get the 0, and for the j, we get the 0, and k, we get negative 1 over 2. After that, we need to include it into the velocity. After that, we do it, we get this value. After that, we need to do a sum integration from this value, so we get this answer. And also of that's question, we need to do we need to find I, j, and k. For this question, we get I same as 1 over 4, and j we get 1 over 2, and k we get 1 over 2 also. After that, we do a calculation, and we get this answer. So that's all.